Okay, so here we are, finally at the Linux Tech in Basics, which is not very different theoretically from what we discussed about Windows. I've just chosen Windows because it's much more prevalent in the business environment. So, uh, what we can say about the similarities and the differences? Let's start from the latter. So, Linux is definitely different from Windows. First of all, because it's basically free open source software that has been developed by many enthusiasts, and the concept of open source software gives it more potential to be secure. Okay, it's not always guaranteed that this potential will result in actual security of the product, but potentially it's more secure. So anyone can go there and read through the sources, and many people do. And they find vulnerabilities and they report them, and the Linux kernel maintenance teams and the various open source vendors, software developers, take that input and fix the vulnerabilities really fast. So patch cycle for a critical vulnerability is much faster for Linux than Windows. Now it's it's comparable, I would say, but back in the day, in the 90s, you could wait a couple of days or even weeks from to update to come from Microsoft, and for Linux it was like the matter of hours. Uh, okay, so what are the main differences? First of all, the file systems are slightly different. If in Windows you see these drive letters that are the start of the directory tree of a file system, in Linux it's normally starting from a single root of all file systems, and then physical devices are mounted to specific directories, normally the subdirectories of media or MNT directory in the root directory. Like that. Yeah, so there is root, normal slash, not backslash used in Windows, but normal slash is called root, and there everything starts. So there are different directories in the root. They are traditionally named by the purpose they exist. Yeah, so they contain different type of data, and that's why binary data normally is put into directories named bin, and there is USR directory for user installed programs and libraries, and there is share directory for shared libraries and shared data and different help information and so on. So this is quite traditional, and I would not say that that's standardized, but yeah, it's common. Okay, so it's pretty much everywhere named the same. So lib contains libraries, modules contains kernel modules, device drivers, and so on. Differences in memory and process execution. From the standpoint of exploitation, they are almost non-existent. Okay, so the equivalent of ASLR and DEP have been introduced into the Linux kernel much earlier than Microsoft did implement them in their operating system. So there are pretty much the same ways of exploiting memory corruption bugs, and there are very similar ways to control and prevent that. So Linux is basically written in C programming language that is a little bit higher level than assembly. So it has these structures, these high-level structures, abstract notions of functions and structures actually, and all that stuff, but it still allows direct access to memory. So most libraries contain really insecure functions like string copy that basically just takes a piece of data and the binary copies it to another address that allows all sorts of nasty things to appear lately in the history of this software. So that happens a lot. Sometimes just misspells a secure variant of a function by its insecure equivalent, and all this remote exploitation drama starts over again. So that's what open source world looks like. And one more very important thing that just in general, you can imagine as everything in Linux as files of some sort. There are block files, there are text files, even pseudo-random number generator in Linux is just a file you can read from internally. So that's quite interesting, and everything of this kind is placed in a root directory named dev. Yeah, so you just come in there and you see if something you can find there you can read from. This is basically a device driver and you can write to some files as well. So for example, dev /sound is your sound card. So a very interesting trick is very popular. But back when I was young, it was really funny. Maybe I don't know what the nice word is, but we just run cat program that basically takes a text file normally, yeah, and shows it on the console. You can redirect the output of that, so you can just take a arbitrary file and take the output of it, yeah, and put it to some device, yeah, or to some file. So we used dev sound for that matter, and we have written the whole operating system kernel to it and listened how it sounds. It's quite zen, it's philosophical. You just hear how the binary code sounds in your headphones. That's quite interesting. You cannot stand that for long, but you should try. And in any Unix-like operating system, it looks like that. So in Linux and FreeBSD, in any HPUX or IBM that's normally like that. All the devices are files. You can read from them, you can write to them, and so on. Okay, so access control that is employed by Linux is slightly different in implementation, but on a higher level, it's very similar. So there are users have passwords, the users are joined into groups, and the groups are having permissions over different files, which represent everything in the environment. Okay, so if file is owned by one user but run by another user, it inherits the permissions of the user that runs that process, not that owns that process, unless there is a sticky bit installed on that executable that lets everyone in the system run this process with the original user permissions of the user that has created that file. Okay, so it's quite more complicated, but if you're trying to figure out the specifics of how it works, you understand, you more and more understand with time that it is much more logical and has more analysis behind that, more mathematics. Yeah, so there are mathematically proven access control models behind that. Whereas in Windows, it's much more reactive. Yeah, so Microsoft has created answers to the questions that business environment generated for the company. Okay, Linux is more natural in that regard. So Other differences in user environment may be, for example, that working from a console is much more not popular, I would say. It's much more productive on Linux. Okay, so there is not much of a user land for console interaction with the operating system in Windows, but Linux generally it comes from that. Everything graphical was the extension of what was going on the console level. So many graphic user interfaces, they are just the wrappers of some console tools that are run in the background while you see this nice picture on your screen. So graphical user interfaces are really cool now for Linux. So they do not reflect the operations of Windows, but they implement all the specifics, all the required user tools, texting processors, web browsers, graphic editors, and all the stuff that is normally available on a Windows desktop is available in a modern Linux distribution as well. But it definitely requires some skill, to use that on a desktop. Still, however, in 2016 we can say that finally we see a real advancement of Linux on the desktop, but it still requires some technical knowledge. You can train an average user to do that. However, to get the most out of Linux, you have to know console, and that's where hacking starts. And there are cases when people are just accused of malicious hacking because they were working from the console or their Linux desktop in the airport lobby. So these are unfortunate cases of low user awareness of what are the different types of operating systems. So console is prevalent in Linux. It's much more productive than in Windows, and for some users it's still much more productive than graphic interfaces for Linux machines. Okay.